actually today talk about the statistics foldable. It's kind of, in a way, a lot of a big summary. And as we get through, I think it's like the 4th page, we've actually done box and whiskers, and a lot of those multiple choice questions that you're going to see in that section, we've done before. Do y'all remember talking about which bricks would be the best bricks to use?
Yeah, for Daniel.
So, yeah, so for Daniel. So this particular page right here for us will be a big review because we've actually done that first lesson. So going back to this, so does everybody have their statistics foldable?
Yes.
We're going to open up the first flap, and we're actually going to do the first one that actually says measures of center. So if we go measures of center, the top it looks like this. The mean is known as the average. It is the what? Okay. The mean, also known as the average, is the sum of the data values divided by the what?
Overall.
Total number of data points.
Yep.
So you add them up and you divide by however many data points you have. So if I had 20 test scores, I add up 20 test scores, and then I divide by 20. Median. It's a data point located in the middle of a set of data. So this is kind of a review. There are the same number of blank values on blank side of the side blank. Both. Both sides of the median. So basically, if you have your median, you may have 3 numbers over here, 4 numbers. You have to have what? 4 numbers over there. So the median is always the number in the middle. What's the mode? It's the data point that appears what? Most often. The mode of the data can also be called the peak of the data. If we had this out and we were actually doing a plot to where we said, you know, this number occurs 2 times, this number occurs 3 times, then it would actually be the one that's the highest peak. Okay, I think we've done some of these before. A whitewater raft can hold a maximum of 1,000 pounds. What would be the best measure of people's weight to know if an entire party was to go on a whitewater trip? Median, mode, or mean? I would want to know the mean. So if I asked myself and looked at the group of people and I said everybody, you know, averages around this many pounds, and you times it by that number of people, you kind of get a guesstimate of whether you could afford to go or not. Number 2, if you're going to open a lemonade stand on your street, but you want to know the best measure of data to use when deciding to run your stand in relation to the number of cars that pass by your street. Median, mode, or mean? That's the mode. Why? Because I want to pick the time frame when I'm going to have the most cars. Like, I'm not going to open my lemonade stand at 10 o'clock at night. I'm going to open it probably at 2 or 3 or 4 in the afternoon when I know there's a lot of cars maybe traveling through. Number 3. Now, ahead of time, I have asked you guys to give me the mean, or to actually put first period in your calculators, and some of you put second period in your calculators. So if you've done that, I want X bar, and I'll draw a line. Over here, I want X bar. Now, what does X bar stand for again?
Mean.
That is notation that stands for the mean. So whenever I do an X bar, so first period, those of you that have it for first period, what is the mean?
I got 79.58, but would you round it up?
No, I left it 79.58.
Okay.
Okay. Those of you that did second period, what was the mean? Anybody second period? Jacob, what'd you get for mean? 87.8, and we're going to make that 87.80 just to carry 2 decimals just like we did the last time. So far, which class seems to be the stronger class? Second period. All right, what's the median of the set of data? It's the middle point. If you went down, remember, scroll down the page. So the median for this one is what? 80. What's the median for second period? 88.5. Very good. What is the mode? Mode is the number that appears most often. Was there a mode in the first list? 71. More students scored 71 than any other one score. What is the mode for second period? 100. So given the fact that the mean and the median and the mode, it looks like in every category, which is the stronger class? So it says write several sentences to compare the class grades, and we're just simply going to say second period or stronger. It's consistently a stronger class. It's just wanting us to draw a reasonable conclusion. So if you were able to compare one set of data to another set of data, what's a reasonable conclusion to come to? So we do know how to use our calculator. So when we used our calculator, we were following those notes that we took yesterday. So we did what? Stat key, and then didn't we edit a list? And we put everything in list 1. Then we went back to stat key, and then we arrowed the right to calc, and then we chose number 1, which was 1 var stats, which stands for 1 variable stats, because we only used 1 list. And then we had to scroll down and it would show it. So you press enter, enter, and you scroll down and you see all the numbers. Everybody good with the first flap? Okay, so now we're going to go down to the next one that says measures of spread, and this will be new. We have not done measures of spread before. All right, I think the top is stuff we have done before. What's the range? The range is the difference between the highest and lowest. What do we call the highest point, though? Maximum. So it would be the max. And the lowest point, which we would call the minimum. So I think they use max and min when you look on your calculator, so we'll use the phrases max and min. So basically we want to know how far apart are they, or is, from the lowest score to the highest score. If I actually have a small range, that actually tells a story versus if I have a big range. Okay? I've had some tests where either everybody did 80s and 90s or everybody did 20s and 30s. And then I had a test that I just gave in my last first and second period math class where hardly anybody scored below 60 and everybody scored between 70 and 100. And I had some students at several that got the bonus and got points higher than 100. So on that particular test, the range was small, but it actually meant that everybody did really well. Whereas if you've got high and low, you've got some high achievers, but you also got a lot of low achievers. Does that make sense? Okay. Quartile. The values that divide the data set into how many? 4 equal parts. And yeah. And they divide them into 25% of the data.
We don't have that.
Okay. The difference between the blank and the blank. What's the interquartile range? The difference between the first quarter and the third quarter. Q1 and Q3. So basically range is from outer to outer, but then inner quartile range, the IQR, I think of it as coming inside to that inner box. Standard deviation, now right here is where we have not talked about it before. Standard deviation, if you highlight any word that we talk about, it's going to be talking about, it says the standard deviation is the average distance that each data point is from the mean. A low standard deviation indicates the data points tend to be very close, and a high standard deviation indicates the data points are spread out. If you don't do anything else, take your pencil or take a highlighter, and I want you to underline the word spread. Okay? How widely spread is this data? That is what we call standard deviation. So they won't say basically how widely spread. They may say what is the standard deviation, but that's what they're talking about. So the more widely spread, the bigger the standard deviation. The less the data is spread, the smaller the standard deviation. Have you ever heard statistics may be quoted in a paper or online or after a poll, and it may say the results of this poll are plus or minus 3 percentage points, something like that? Well, if you ever hear data like the statistics, the standard deviation of this poll is plus or minus 2 points, that's pretty small. That means everybody's pretty close to the average. But if it says plus or minus 10 points, that means you could be 10 points higher than the average, or you could be what? 10 points lower. That's a much larger spread of data. So if you have a large spread of data, the standard deviation is going to be big. Now, the standard deviation turns out to be something that you see on your calculator screen. Would you highlight or underline standard deviation, which has, guess what letter in it? Standard deviation, so guess what it has in it? S. And it's the SX. Yes?
Was it like that wood thing we did all that? Where it was like, it was closer together.
I'm not mistaken. First period and second period actually are the same set of data you already have in your calculators. Is everybody good? If you haven't already, would you please go back and find the values for one variable stat. So go back and do it so it's fresh on your screen. If it's not on your screen, go back and go stat, calc, number 1, enter, enter, until you see the values on your screen. All right, we want to talk about the range. What's the high and the low for first period? Can you guys look at your max and your min for first period? Some of you have it. What are my max and my min for first period? I need to go back there. So it's 100 is the highest. And what's the lowest? 34. Oh, so for first period, you should have second period in yours. So for first period, is it 134? So what is the range for this data? It's 100 minus 34. 66. Everybody good? All right, now let's switch. I'm going to ask second period. Those of you that have the data for second period in your calculator, what's the highest and lowest score? I'm going to say it's 100. 166. So we're going to subtract those two. So the range is much, much closer.
That's cool.
Okay.
100 minus 30.
I know. Wonder if that was on purpose. All right. Are y'all down the page looking at your 5 numbers?
Yeah.
For first period. Can you guys go find the IQR for me? That's your Q3 number minus your Q1 number. So what are the 2 numbers you're using?
91 and 7.
What's Q3 for first period? What's Q3 for 91?
I think
I had 90. So the Q3 turns out to be Q3 turns out to be 93. Q1 turns out to be 71. So when we subtract, we get what? 22. So the inner box part, like if we had a box and whisker, that would be how far apart the box is. All right. How far apart is second period? What's your Q3 and Q1? 94.5 minus 80.5. And so the difference is 14. So your box is a lot shorter, a lot closer together, indicating the scores are not very spread out. What I want you to do is you guys have been looking at the 5 numbers to get the range and the IQR. Now scroll back up and look for the standard deviation, which is SX. Okay, it says SX. So what's the SX for first period? 15.19. That's the SX. All right. What is the standard deviation for second period?
8.81.
Okay. So the SX is 8.81. Did you say 8.81?
It was 8.808.
Okay, that's fine. Did you guys confirm those? I kind of want to make sure everybody has a chance to put hands on their calculator. Are you seeing those same numbers? So standard deviation. So what did we say standard deviation was the same as? Standard deviation. What word did I tell you to underline a while ago? Because I want you to remember that is what standard. It's the spread of the data. Which class had the bigger spread of data? First period. The spread of data is more like 15 units. So if I find the middle number, basically most of the scores are either 15 points above that or 15 points below that. That's where the majority of the points are, okay? Here's the thing. When I go 15 points above and below, that's a 30-point wide spread in the middle. This one's only 8. So this one's going to be closer to about 16 or 17 units apart. So this first period is way more spread. So that's what I want you to say. Context of spread. First period has a much larger what? Spread. And what is the correct term for spread of the data? Standard deviation. Okay. All right, so first period has a much larger spread. First also has a larger range. Second period has a smaller range less of a spread, so less standard deviation. So they are the better performing class. So this teacher should be better performing class. So her second period, those students consistently score better. They don't have as much range, which means their scores are closer together. They don't have as many highs and lows. That kind of generally indicates a very strong overall group of students. Right. So now let's turn the page till we get to the part where we're going to describe the shape. So for the first time, we're going to talk about skewed to the left. A graph is skewed left. That's skewed, not skewered, not like the barbecue where you have a stick, a sharp stick, and you put meat and vegetables on it. That's a skewer. This is just skewed. It's skewed to the left when there are fewer data points on the left. The shape of the data when the graph has a tail to the left. In other words, I have a tail to the left, and then here's my data points. In other words, I have a lot of extra space on the left-hand side that I don't have on the right-hand side. So that's what it means to be skewed to the left. Okay, opposite of that, skewed to the right. A graph is skewed to the right when there are fewer data points on the right. Okay, and the shape of the data when graphed has a tail to the right. So all my data points must be on the left, and I have this long tail on the right. So this one's skewed to the right. Symmetrical. Okay, the graph will look balanced or even. That would be a word that would apply too. The shape of the data when graphed resembles a bell curve. And a lot of times in the stats class when I had it in college, it kind of looks like a normal, perfectly shaped bell curve. It goes up, and the tail on the left pretty much matches the tail on the right, and it's even in the middle. So we don't have it stretched out on either side. An outlier. An outlier is a value that is much greater than or much lesser than other data in the set. In other words, if you were a good student and you consistently made, 85, 90, 92, 95, 88, 100, like you typically made very good scores, A's and B's all the time. And then one test, something happened the night before, maybe you were a sports athlete and you got caught at a game, could not study, and then all of a sudden you made a 43. Well, compared to all of your other scores, that 43 is very untypical of what you normally do. So we would consider that to be an outlier. We would consider that to be a value that is not true to who you really are as a student. So that value would kind of start almost be ignored. It's kind of like, some teachers will say, I'm going to drop your lowest test score. Well, for the student that just has one low test score, boom, that's perfect. So that one time that they didn't get to study, that one time that they had a much, much lower score than normal, if you drop the lowest test score, that's the student that would benefit the most. That only has that one. Now, if you have 2 or 3 scores that are low and the others are high, dropping one may not hurt as much or help as much. Number one, we want to talk about, so symmetrical data, the center is the mean. So whenever I was drawing symmetrical data, that's when the top and the bottom matches. The center is in the mean right here. So the mean is actually at the peak of the data. That's your mean. That's your average. So that would be where your X bar is located. And the spread of the data would be your standard deviation, which is your SX. Okay. Skewed data, the center is the median. So if I have it skewed, so what if I have a tail to the left? Okay. If my tail is to the left, then this peak right here, that's really truly not the mean. That's actually more like the median. Remember, that's a measure of central tendency, and it would be the middle number. But you still have this tail. Chances are that the mean is probably somewhere over here, and it's probably lower than the median because I've got that outlier. I've got those numbers to the left that are lower. It's dragging me down. So it might push my mean a little bit farther left. Okay, let's talk about 1 and ABC. We want to look at the data. So I'm not sure what the data is for. It doesn't really matter. Let's to consider 15, 25, 35, 45, 55. And all of a sudden we toss in 115. Wowza, 115. So it's kind of like I'm bebopping along. I've got all these data. I got this one, and all of a sudden way out here at 115 is that one odd data point. So, 15, 25, 35, 45, 55. They're all right here in this first group, and then boom. So it looks like to me it's got a tail that's going out to the what? It's going out to the right. So number one, we would have to say is skewed to the right because it's got that one number that's on the right-hand side of the data, way over there to the left. Okay. Letter B. Let's look at this data. I got a 15. Then it jumps all the way to 75, 85, 95, 105, 115. So then it's like 15 is really, really low. So if I did this one really, really low, then all my data points are more over here. So in this particular case, 15 is super, super low, and all of the other data points are over here in this curved part. So this time my tail is to the left. So my tail, that extra long section, is actually more on the left side. Okay, so this data is actually skewed to the left. All right, so let's look at this. 15, 25, 35, 45, 55, 65. That's very consistent data. And so since it doesn't really have a value that's extra low or a value that's extra high, this would be an example of data that is very well balanced. There's no extra, extra low or extra, extra high value. I guess that better be described according to the directions as symmetrical data. Okay. Number 2 says use a highlighter to locate the outliers. So if I'll use my highlighter, is there any outliers in this one? I think since I've got a nice curve right here, okay, definitely those points are on the left. Here's what it looks like in a box. Y'all see this big tail on the left, which kind of sort of goes in with this tail on the left. So since I have a big long tail on the left, this one has a matching tail on the left. These two are kind of sort of showing you the same data. These are definitely what? Skewed to the left. So we picked our highlighters up and we highlighted those two right there. Let's go to number 3. It says use a highlighter to locate the outliers. So my outliers this time, see here I have these two outliers right here. So my data, if I simply followed the curve, would come way over here and boom. So I have this tail that goes to the what? To the right. Here I have my tail on the right hand side. And so that means that this data is skewed to the right. So it says this time, use a highlighter to trace a bell curve that makes the graphs symmetrical. So this time if I grab a highlighter, I'm going to grab a pink, and I believe as I trace the tips of the thing, and that's not perfect, but anyway, that would actually be pretty darn symmetrical data. Let me go back up here and touch my highlighter again. So as I come down here, that's a bell-shaped curve. So I'm touching the points as I go through. Well, it doesn't like that. It wants to change it to a line. So that is very symmetrical data. Also, look right here. Notice how my whiskers, if it's symmetrical, are very similar to being the same shape. So again, this is symmetrical data. I don't have one whisker that's longer than the other. They're both about the same length. So it looks like this length on the left and this length on the right are the same. So this is a very balanced set of data. Thus, it is a symmetrical set of data. Now we're going to move on to the next one, which is going to be histograms and box plots. Histograms and box plots. Histograms divide the data, subdivide the data into intervals. Sometimes we call those bins. Okay? And so when we look for intervals, that didn't really print too good. I-N-T-E-R-V-A-L-S. Intervals or bins. We're talking about a space that's like right here. See how this would be a bar, or it's an interval, okay? And it probably goes from something to something. So we're kind of in between numbers. And we use rectangles, usually columns, to show the frequency or how often it occurs. So we show the frequency or the count of the observations. The choice of the size of the intervals may vary. It could be between 10 and 15, between 15 and 20, or it could be between 10 and 20, or it could be between 0 to 100. It depends on how you spread your data out. Which statement could be true about the data set? Okay, which statement can be true? And it looks like I have multiple choice here. All right, the means of the data sets are the same. So when I look at a set of data, I'm just going to simply quickly trace this set of data. It looks like my mean is right straight up the middle. So if I look at my mean, it looks like my mean, which X bar is your mean, is upset of the set of the data. And to me, it kind of looks like it's between 20 and 30. So I would estimate that the mean is 25. Let's look at the other set of data. The other set of data, if I started here and then drew my data set, okay, and I go to the middle, the peak occurs, oops, I'm off a little bit off, but a peak occurs right here between 70 and 80. So I think my mean is about 75. Does that look good? So it actually says the means of the data set are the same. No, they're not. 25 is one, 75 is the other. Letter B, the means of the data sets are the same. Nope, they're not. Number C says the range, and it's mentioning range. So let's go ahead and let's talk about range. But it looks like this starts at what? 0, and it goes as high as 50. So my range for the first one is from 0 to 50. That's 50 points of range. What about my range on the second one? Well, it looks like it starts at where? That looks like 50, and it goes as high as 100. So from 50 to 100, the range here would also be 50 units. So while the means aren't the same, the range is the same. All right. So A and B I crossed out because the data sets were not the same mean. The range are the same. Ooh, I like that one. Oops. I hate it when I do that. So let me re-engage my pen. The ranges of the data sets are the same. That's true. D, the ranges of the data sets are the same. That's true. And the data set 2 has the greater mean than data set 1. Well, data set 2 does have 75. Data set 1 just has 25. So I believe C is definitely correct. Set 1 does not have the greater mean. Okay. Now, let's talk about a box plot. A box plot shows the 5-number summary. And we did this box plot. It's usually called a box and whiskers. And you kind of sort of remember, this is actually going to be your minimum, which usually could be an outlier. The highest point could be your maximum, which could again be considered an outlier. And then the first 25% of the data occur at the beginning, and then this would be Q1. I know these are already marked. This one right here in the middle is your median because that's the middle number. It's also called Q2. And the third number is 20. See, all of these are 25%, 25%, and again, this is the last 25%. So this is Q3. So those 5 numbers can be found. We have been practicing doing those in the past couple of days. So we're going to stat, edit, input our data, go stat, calc, number 1 vars, go down the page, down the screen until you see the 5 numbers. Now, number 2. I believe when we did number 2 in class, we took a look at this box plot. We noticed the lowest is 5 and the highest is 15. And I noticed that the first group had a 4 in it. Well, 5 is the lowest it can be, so there can't be 4, so I know A is not my answer. And then what I did is I simply had you guys, I think I divided you into 3 groups, and I had one group type in set B, and the second group type in data set C, and the second group type in data set D. Because this is my minimum one, and Q1 is 6, Q2, or the median, is 8, Q3 is 12, and then the maximum turns out to be 15. And so if I am remembering correctly, the one that actually matches those 5 numbers when I put them in the data set is actually set B. If we typed them in, I think one of them had, either the Q1 or Q3 was just a different number. And that was we've done that in the past, so I'm kind of sliding through it a little quicker. Number 3, movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box and whisker plot represents the data for the number of tickets sold in hundreds. So there's not one person that went, there's hundreds of people. So it looks like the lowest day we had 100 people show up. That would be the minimum number of people. Looks like the 3 is Q1, and that represents 300 people. 4 is actually Q2, or that's your median, it's your middle number. That represents 400 people. This is at 6, which represents 600 people, and that's your Q3. And then it looks like your max occurs at 9, and so that would represent 900 people. So that information is just kind of getting it out there. It says, which conclusion can be made? The second quartile, or Q2, is 600. Nope. The second quartile is actually 400. So A is out. The mean of the attendance is 400, the mean. Well, I don't really have mean in my box and whiskers. I have the median, but I don't have the mean. So I'm thinking that's not it, but I'll wait. The range of attendance is 300 to 600. Nope. The range goes all the way from 100 to 900. So the range is all the way from the beginning to the end. So I believe from 100 to 900 is 800, so it's definitely not C. 25% of the attendance is between 300 and 400. Well, 300's here and 400's here, and that is my Q1 and Q2. That is correct. 25% of the data are in that first box. The first 25%'s here, the third 25%'s here, and the last 25%'s here. And so that kind of tells me that D is correct. Based on the box and whiskers plot, which one is false? It means 3 of them are true, 1 of them is wrong. So it looks like I have my minimum at 2, my Q1 at 4, my median, or Q2, at 7, my Q3 is at 11, and my max is at 12. So the median is 7. That's true. The range is 12. Okay, if we remember, range is from the lowest 2 to the highest 12. I think my range of this data is going to be 10 units. So range is not 12, so I think that's the false one. The first quarter is Q4, well, Q1 is 4. The third quarter is 11. Sure enough, Q3 is 11. So the one that was false is B. Number 5, I believe we've done this before. We need a contractor that's as close to 2.5 inches as possible. And while Adams blocks or bricks are a pretty good contender because they are pretty close to 2.5, gee, Adam can make some really big bricks at times and some really small bricks at times. So I think the brick maker who seems to do the most consistent job that has the mean pretty close to the 2.5 range is Daniel's Bricks. So his company would probably get the award. Okay, now we just have some problems to practice. From this point on, number 1 is Kyle scores are the follows. If Kyle makes a 98, which of the following? So now we're listening to, we have mean, that's the average. We have standard deviation, that's the SX. We have range, which is the high minus the low. And then we have the IQR, which is Q3 minus Q1. So it's actually mentioning all of these different things we've been talking about. Well, I'm going to do something. I'm going to list these data points in order. I'm going to say 76, I think, is the lowest. 84. I'm going to list 87 next. 90. 91 is next, right next to it. 92. 96. And 103. Pretty consistent data overall. So I want to imagine, if we could, what if I came in here and I just drew a normal balanced bell-shaped curve on that data. Then it says Kyle makes a 98 on his next test. So right now, if I go right to the peak, this would actually be where my mean is located. So it looks like my mean is somewhere in the low 90s. I am averaging in the low 90s. So it says if Kyle makes a 98 on his next test, is my mean going to be increased? Is my average going to get higher? It's a distinct possibility. Because if I'm averaging in the low 90s and then I have a high 90s, it should improve my grade. So I should increase my mean. Okay, let's just investigate the rest of them. The range would increase. Well, I'm not so sure about that. My lowest was 76 and my highest was 103. And if I just came in here and said, you know what, I'm going to put a 98, that 98 is not going to change my range. So B, the range does not increase at all. Actually, the range stays the same. The interquartile range decreases. Well, nope, looks like I would be, going out a little farther than the middle. So I don't think that gets smaller. The standard deviation, remember what standard deviation is? Standard deviation is the what? Spread. And it said it would what? Decrease. In other words, I don't think this is coming in at all. I don't think it's getting smaller. If it was getting smaller, it would look more like a peak there. But by having 98 would not make that get smaller. So I believe we were correct on the first. The answer is the mean increases. Okay, so the way I was able to reason out my answer is I simply took the numbers and I listed them in order. I just simply sketched what I would think would just be a very general normal bell curve, and then I actually try to examine where that value is added. Let's try number 2. Mrs. Patterson's bowling scores for the past month are the following: 192, 226. We'll do the same thing again. I'm going to take those scores and I'm going to just start. The lowest one I think is 170. And then her next one is 196, a little space there, or 192, and 196, and 197, which is right next door, and then 200, and then 205, and wow, then she bumped it all the way up to 226, so I'll spread that out. So it looks like this would be my normal bell-shaped curve. And of course, I still have the previous bell-shaped curve. And so since we have completed number 1, I think I'll just erase this so that my board won't be quite so messy. So I'm just going to just naturally distribute that. So that's kind of even. If she scores the following on her next 4 games, so I'm going to put this in here. 241. Wow. 241. She blew her average out. 198. Right here in the middle, another 198, 162, ooh, had a bad day. Okay, and then 230. Okay, so she really did change her, yeah, she changed those. So she scored those on the next 4 games. The data would become less peaked and more widely spread. Less peaked and more widely spread. Okay, let's talk about the widely spread first. Well, I was going from 170 to 226, but because of these new scores, we're now spreading it from 162 all the way over here to 241. So definitely more widely spread. More widely spread, not less widely spread, not less widely spread. Now the next question is it going to end up getting less peaked or more peaked? Well, it's almost like a string. What do you think of a string? So if I came in here and I had to take my string and stretch it out on each end, right? But then I had one score in the middle. It almost looks to me like it would serve to make it peak in the middle a little higher, and it would take my string and it would stretch it differently. So it looks to me, and this is just an observation, this is less widely spread than it was before. See the red line? Now I've got a pink dashed line. So I think the best explanation is B. The data distribution would be more peaked and more widely spread. So all right, to clarify, I just realized what I did. It is less widely here, but it's actually, just to clarify, it's actually more widely spread overall. Maybe less spread in the middle, but it's more widely spread because from the front to the back, it's stretched out a lot more. Okay, just to clarify that. B is the correct answer for that one. Number 3. Which set of data would you expect to have the greatest standard deviation? Okay, standard deviation is what again? Standard deviation. What word can we use for standard deviation? The word that we want to think about is spread. Which set of data would you expect to have the greatest spread? So if we were kind of the heights in centimeters of all the students in first grade. So I want you to think about first graders, just the students in first grade. You know, some are shorter and some are taller, but which ones would have the greatest spread? So I want you to just consider that. So we have all the first graders, just the students. Letter B, the heights in centimeters of all the first grade teachers in the elementary school. So this time it's just the teachers. Okay, think about adults. So we're not considering students, we're just considering adults. There are some adults taller and shorter than others. So B is just considering the different teachers. Letter C, the heights in centimeters of all the first grade students and all of the first grade teachers. So then we have first grade students who are going to be fairly short, and all of the first grade teachers who are going to be adults who are taller anyway. And then of course now you got from short first graders to tall teachers. E or D, the circumference in centimeters of the wrist of all the students in your class. Think about the length of your wrist if you tried to wrap your fingers around your wrist. If you wrap your fingers around your wrist, the circumference, does it change a lot? Is there a lot of spread? Is there a lot of variation in wrist? Usually not. The foot lengths in centimeters of all the teachers in their school. Okay, that's going to vary because if you have some really tall men, you could have a long foot. You have some short women, you can have a short foot. But think of the length of a foot. Short foot, long foot. Which would have more spread? I hope that we can narrow it down to C as a possibility, E as a possibility, and I think we should be able to safely say, you know what, the rest of those I'm going to say are not going to be as big. So short foot, long foot, or first grade teachers and students, which one would be more widely spread? Greatest standard deviation, I think, would probably come from the teachers and the students. Because if you have a short student and a teacher, you're going to have more than you would have if it was feet. So number 3 is going to be C, the heights in centimeters of all the students and the teachers. Number 4, Abby scored. All right, number 4, Abby scored 87, 93, 96, and 80 on her first 4 history quizzes. What score does she need to get on her 5th quiz to have an average of exactly 91 on her history quiz? To have an average of exactly 91. So let's just think about what we're doing. What we're going to do is we're going to add up all the scores, okay, and since we're going to end up having, up to her 5th quiz, we're going to end up adding and dividing by 5. And we want it to be what? What do we want it to add up to be? We want it to be exactly 91. So basically, I need to know what score would I add to make it equal to 91. So let's just see if we can put this into perspective. If I made 87, I would add that to 93, which add that to 96, and add that to 89. And then basically, I'm going to have to add in some other quiz score that I don't know what it is yet. But when I add them up and I divide them by 5, I know what I want the answer to be. I want the answer to be what? 81. So in a way, you could actually represent this as an algebra problem. Okay? Set up this way. So what I could do is I could say, okay, 87 plus 93 plus 89, or 96 plus 98 is, and add those up. And all right, I just picked my calculator up, and I added 87 plus 93 plus 96 plus 89, and I got 365, which is still going to be added to my unknown quiz score X. When I get done with that, I'm going to add them up and divide by 5, and I know I want the answer to be 91. So basically, I need to solve for X. So what I want to do is I'd like to get rid of that divide by 5. So if I multiply this side by 5, then I have to multiply this side by 5. So if I 91 times 5 is, calculator, 455. Since I don't have the denominator, I just have 365 plus that X quiz score. So if I subtract 365 from both sides so that I can get X by itself, it turns out X is 90. Is that one of my answer choices? Yes. Now, if you are someone who's like, I don't think I want to go through all that, the only other option you have is to simply put in, simply just work them all out and check them. You could guess and check. So I can do 87 plus 93 plus 96 plus 89 plus, and then you could just check. Try 90. Divide that by 5. So you could just have tried 90, see what it gave you. And then you could, if that one hadn't worked, which it would, then you could have actually tried the next one. You say, I'll check 94. So what if I added 94 there divided by 5? Would I get 91? So you could just guess and check. That's an alternate way to do it. You might have to check 4 different numbers before you could possibly get the right one. Or you could set it up and solve it like a little algebra problem. Number 4. So I think that puts us ready for number 5. The number of points scored by a basketball team in the first 8 games of the season are shown. What happens to the data distribution? Now we're doing the less peaked and widely spread stuff, which means now we're talking about standard deviation. As soon as I read the word widely spread, I'm thinking, you know what? That is the standard deviation that we talked about earlier. Okay, I'm going to do like I did before. What happened to the data distribution the team scored? Okay, so here's my strategy. I'm going to put 46. Oh my goodness. Okay, I'm looking at this original set of data. So 46 is the lowest. Then 54. Then 58. Then 61. 62 is right next to it. And 67. 71. And 80. So this is my set of data. So I'm imagining my spread being balanced like that. Then it says, what would happen to the data distribution if the team scored these? So now I'm going to add 42. 42 is going to spread me out even farther. 59 is going to go right here. 62 is another 62, which is going to bump this up in the middle. It's going to kind of push up on this. And then 63 up right next door. So it's going to actually bump it up in the middle. And 65 is still right here. So basically, it's bumping it up in the middle because I've got more. See, that's frequency. So the more I have, the higher that peak goes. So I wonder what's going to happen. Is it going to be less peaked or more peaked? Well, I hope that when you see, you know what? By the time I add 62 and then 65 and then let's see 62, 63, and 65, since I add all these numbers, it's going to peak that. So it's going to become more peaked. It's not going to become less peaked. So I'm going to mark out letters A and B. The only thing I have to decide now is, would the data distribution be more, less, or more widely spread? Well, more or less widely spread. I hope you can see that it used to go from what, 46 to what, 80. That was the original. So then what happened? As soon as I scored lower than 46, then I have to stretch it out. So actually that's more widely spread and more peaked. So D is the correct answer. Number 6, table shows the population of several cities. What would happen if Tinkerton, with a population of 50,000, was added to the data set? So I'm going to put these all into pillboxes. That's a really, really small town. So 500 people is way over here, all off by himself. The next biggest town, G, has 15,000 people. That's almost an outlier in this data. Actually, it is an outlier. And then I have what? Let's see, 15,000. So I have this one, then I have 15,000. Looks like I have 21,000. So here's 21,000. And then I have 22,000 right next door, like right on its heels. So 22 and 21,000. Then I have 25,000. That's pretty close here. Then I have 30,000. These are big numbers. Wish I hadn't did so many zeros. And then finally I have 40,000, which is up here. Okay. So if I stretch this out, okay, not quite. Looks like it's skewed to the left, doesn't it? But here it says, if Tinkerton, with a population of 50,000, well, 50,000 is way over here. That's even more people than any of the previous cities. Say, does the standard deviation, remember what standard deviation? Remember, it is the spread. Pretty sure the spread gets what? It does not decrease, it actually what? Increases. A is not true. The interquartile range, what's really hard to tell where the interquartile range is, but I don't think it increases. If the range gets wider, it makes sense that the interquartile range would also get wider. So I don't think that, and we really don't have interquartile range numbers anyway. The range decreases. If I have to go even farther than 50,000, definitely the range does not decrease. The range does increases. The mean increases. So if I were to add up all the original cities and divide by the number of cities, I would get the average population. What would happen if you added an even larger population? It's kind of like with test scores. If you were averaging a certain number, like 80 on your test score, and then you made a 95, you would hope that that would push your average up, and that's exactly what we want to happen. So D, the mean, would increase because we're adding a much larger value to our set of data. Okay, number 7. The set of 9 data points is shown below. The statement is true if the 10th data point of 45 is added. Wow. Now I'm just looking and I see 3, 5, 7, 8, 9, 9, and then I have 10, 11, and 12. Wow. I don't know if these are errors on a paper or errors in a box. Let's just say they're errors in a game. So here's the number of errors, right? So it looks like we got a peak of 9 errors. But Jesus, we go play the state champion and they got a super fantastic quick guard and he steals the ball all the time. Now all of a sudden we got 5 errors, 45 errors. That's crazy. So the number in the middle is actually see, that's your mean. That's your mean, not your median. That's your mean. At the peak is your mean when it's on this kind of data. Will the mean and the median both increase? Possibly. The mean will increase, but the median will decrease. Now, maybe the best way to do this is to let our calculator do it for us. Here's a way to do it. We're going to check this out since it's asking about mean and median. So here we go. I want to go to my stat key. I'm going to edit. I'm going to take out L1 and clear it, go back down to my list, and I'm going to enter these in. 8, 11, 12, 10, 9, 7, what is that number? 5, 5, no, not 55. So 7, 5, 3, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, got them all in there. I'm going to go ahead and do one var stats. So I'm going to calc number 1, enter. So 8.2 is my mean, and my median is 9. So X bar, my median is 9, and my mean I think was 8.2. Go back up to the top. Yeah, X bar is 8.222. So that's what it is with the original set of data at the start. Now what happens when I add in a 10th data point of 45? So I'm going to go back to my list. I'm going to go to stat. I'm going to edit. And I'm going to go down here and I'm going to toss in as the 10th value, I'm going to toss in 45. Then I'm going to go back to stat key and I'm going to recalculate the new mean and so forth. So what happened is my mean changed to what? 11.9. So my new mean, these are my new numbers. After I added, so 11 point, what was it again? 11.9, and the median is 9. The median is 9. 11.9, the median is 9. What do you notice about the median? Remember, that's the middle number when they're lined up lowest to highest. So the median did not change at all, but the mean did change. So which one of those is the correct answer? So once we see how it can work out with actual calculations and numbers, I think it says the mean will increase, but the median will remain the same. So C is the correct answer for number 7. Oops, still need to add a page. 8. The table shows the weights of 8 different bears at the zoo. 8 different bears at the zoo. So if I put them all in, I can talk about the mean, the weight of the pair. All right, I'm going to read that again just to make sure I understand what's happening. The table shows the weights of 8 different bears at the zoo. If the weight of the polar bear, okay, the weight of the polar bear is removed, which statement is true? The mean decreases more than the median. The mean decreases less than the median. The mean decreases more than the median because the mean decreases. Okay, so we're comparing median and mean. Might be better just to type these in. So let's go ahead and get our calculators, and we'll clear out that last data. Let's enter the new data in. So go to stat. We're going to edit, and we're going to go up and clear the list. So hit the clear key, come back down. 225, enter. 300, enter. You should have a calculator in your hands. You should be actually typing these numbers in at the same time I am, so that you are getting that practice and your fingers will know what buttons to press. I'm talking into 550, enter. 200, enter. 1,000 pounds. Wow, he's big. So polar bear's a big guy. 300, 280, and 100. Poor little sun bear. He's a wimp compared to the polar bear. So those are the 8 different types of bears. So we have 8 different bears. It's waiting for the 9th one, so I've got them all in there. It looks good. So stat, calc, number 1, press enter. 369.37, 369.37, and the median is 290. 369.37. 369.37, I think. And then the median is what? 290. Okay, so the median is 290. Let me double check that those numbers are correct. 290. Yeah, 37. That looks good. So I guess it could round to 38. That's pretty good. Now, what did it ask me to do? It asked me to what? Remove the polar bear. So if I remove the polar bear, got a technical glitch. Let me fix it. So if we remove the polar bear, so that's what we were saying, remove the polar bear. So I'm going to pull up my data. I'm going to go back to stat. I'm going to go to edit. And I'm going to go down the list to 1,000. And I'm going to delete the number. So now when I go down the list, instead of having 8 polar bears in there, I only have 7 because it's waiting on the 8th one. So now I'm going to go stat key, arrow to the right to calc, number 1, enter. And the median is 279.285 or 279.29. 278.29. 278.29. Wow. The mean weight of the bears really went down quite a bit. Let's check out the median. So when you go down here, the median actually changed to what? 280. All right, so here we go. See if which one of these matches. The mean decreases more than the median because the polar bear is a higher outlier. Huh. Well, if you do look, if you had these lined up and the poor little old, 100-pound sun bear, and then you've got a 200-pound panda bear, and then you got a 225-pound Asiatic black bear, a 300-pound black, 280, then 300, 280, then 300, then 550. Wow. So by the time I get to 1,000, he's way over here. So the data does have a big outlier. So 1,000, that makes a lot of sense. So let's look at the next one. The mean decreases, the mean does not decrease, so that's a false statement. The mean does not decrease. The mean does not decrease. Actually, oh, sorry, I'm thinking of the wrong thing. It's been a long day. The mean does decrease less than the median because the polar bear is a high outlier. Well, it didn't decrease. It did decrease, but it didn't decrease less than the mean. The mean only changed by 10. It only went from 290 to 210. This other one changed by like however many. That's quite a bit. From 369 to 278, that's like 70 or 80 pounds. So it didn't decrease less than the mean. The mean decreased more than the median because the high value balances the low value. It doesn't balance it at all. It's way too high. The mean decreases less than the mean. It did not decrease less than the median. So the best one is A. Best one is A. Just trying to talk you through it just so you understand how we got that answer. Write a sentence for each. Why does the shape of the distribution of incomes for professional athletes tend to be skewed to the right? So let's remember what skewed to the right is. So we got a lot of players down here. Then you only got one. You got 1 or 2 over here. So I have a high here. So what does that mean in terms of incomes for professional athletes? Professional athletes, how many professional athletes are getting paid the big bucks, like the mega? Okay. There are only a few. Only a few professional athletes get really high pay. So even though LeBron James is making multi-millions, there's only 1 or 2 players on a team who's making quite that much. Everybody else is probably getting just 1, 2, 3 million. Of course, millions of dollars is still millions of dollars, but they're not getting like 20 million. So there's only a few that get the really high pay. Why does the shape of the distribution of test scores on a really easy test tend to be skewed to the left? Okay, skewed to the left, right? So here's the left. And then what does that mean? I got more scores over here to the right, so I got a tail to the right. So if it's a really easy test, what does that mean? Okay, really easy. More students scored well. Only a few were low. So if it's a really easy test, everybody's making high grades. So only a few students are making the low grades, and everybody else is making all of these higher grades. Why does the shape of the distribution of heights of the students at your school tend to be symmetrical? Well, basically, you've got girls, you've got boys, then you've got younger boys, and you've got some older girls. But by the time you balance everybody out, the shape of the curve tends to match that of a population of people. So, and pretty much we're all achieving high school adult age. So we don't really have that dramatic difference in heights as you would from like elementary to high school. So in high school, most high school students, most high school students can't even write. Most high school students are close in height. Okay, we don't have anybody, unless you have some little people in your school, we don't have any 3-foot tall people or 7-foot tall people. You know, in our school, we have people that average between 5 feet to 6 feet, maybe a little of so. So that's not a very big range of people. We don't have any really super short people or really super tall people like Taco Fall. Let's take a look at the very last one. Della wanted to find the best type of fertilizer for her tomato plants. She purchased 3 types of fertilizer and used each on a set of seedlings. After 15 days, she measured the heights of each set of seedlings. The data she collected and the plots are shown below. Write a brief description comparing the 3 types of fertilizer. Which fertilizer do you recommend Della use and why? So, when I talk about fertilizer A, this is the plant heights, right? Plant heights. So here's what I'm noticing. How tall did fertilizer A grow the plants? Well, looks like they got maybe between, say, 2, 4, 6, 8. Looks like they're around, what, 7 feet tall? Okay. If that's as tall as you want them to be, then I guess fertilizer A has done the job. But what about fertilizer B? And that's just the high end. Most of the plants are actually averaging about 5 feet tall. Okay. So that seems kind of short compared to some of the others. What about fertilizer B? Fertilizer B averages around 11 feet tall. Okay, but the highest got up to around maybe 17, 18, but the short ones only got 6 feet tall. So there was a wide range of fertilizer here. Okay, what about the last fertilizer? Well, the last fertilizer, and these are all the data points, and these are the box and whiskers. Looks like the median falls somewhere around 11 feet, so very similar to fertilizer B. The highest ones only got to about 16 feet, but yet the lowest ones got consistently above 8 feet, so let's say about 9 feet. If this was the data that you had, would you pick fertilizer A, fertilizer B, or fertilizer C? So looking at the box and whiskers plot, what do we notice? Here's my observations. A, overall, the lowest heights. All of the plants in this one, so lowest heights. Okay, even though I had some get to 7 feet, overall, they're very low. Probably wouldn't pick A for that reason. Apparently, I kind of would like to have a little higher plants. Fertilizer B, they had a good height, good median height. So 11 feet, and even fertilizer C had 11 feet, a good median height. But what do you notice about fertilizer B? You had a larger standard deviation. In other words, there were what? There was a lot of variation between the heights of them. There's a lot of spread to that data. From 6 feet to 17 feet, that's 11 feet. So you could have some really tall ones and some really short ones. The average might be 11, but you know, do you want the short ones and the high ones? Or do you want one that's closer to 11? Now, letter C also had good median height. Okay. Less standard deviation. I'm just going to abbreviate that SD. Less standard deviation. So actually, I would conclude that C has a more consistent height range. Like you don't have as many highs and lows. There are going to be some shorter ones. There's going to be a few that are taller, but they're not going to be quite as varied as fertilizer B. If it were me, again, this is open to interpretation, but if it were me, I would probably say, you know what? C is my better choice. Okay, that wraps it up.